All right, so now let's go ahead and talk about sex influence traits. So, sex influence traits, not on sex chromosomes. This is where a lot of students get really confused between sex linked, sex limited, and sex influenced. We're going to talk about sex limited in the next video, but both sex limited and sex influenced are not on sex chromosomes, they're on autosomal chromosomes. This is in comparison to sex linked that are on the sex chromosomes. That's chapter 4. So, really important to remember they are not on the sex chromosomes. And as you can see by the name, sex influence, the trait is influenced by the sex that the individual is. So they're influenced by if the person is male or female. So another way to think about this is that the same trait will be dominant in males and recessive in females, or dominant in females and recessive in males. So like hair color, we would say that brown is dominant in males but recessive in females, or something like that. So because it depends on the sex that the person is, that means that this trait is going to behave differently if it's with a boy versus a girl. And that means that whenever you're solving a problem, treat it like a dihybrid. This is going to be the easiest way to solve these problems. Your first trait is going to be the autosomal trait, where it's like big A, little a, or whatever letter you like to use. The second one is just going to be the XXXY. So I have a non-genetics analogy for you guys. So think about sports. When you think about sports, you could say that football is dominant in males but recessive in females, and volleyball is dominant in females but recessive in males. So football, you have a lot of guys playing it, but not a lot of girls. And volleyball, you have a lot of girls playing it, but not a lot of guys. So the sport that you play, or that like your parents enroll you in when you're growing up, is going to be influenced by which sex you are. And if this last point helps you, great. If it's confusing, don't worry about it. You play sports with your body. Your body is your somatic cells that have autosomal chromosomes in them. So that's a way to remember that it's on your autosomal chromosomes. If that doesn't help, don't worry about it. Just remember sex influence is always autosomal chromosomes. So now let's look at an example. So I have spikes in cacti are sex influence traits. They are dominant in females and recessive in males. A heterozygous female is crossed with a spiked male. Draw the ratio for their children. So first, whenever you start these problems with sex influence trait, just take a moment to write off to the side the genotypes for females and what those phenotypes would be, and the genotypes for males and what those would be. And another thing that I think you guys will find helpful with sex influence, so I would recommend against using big A's and little a's for sex influence. That's because if we were to say a big A, that would be dominant in females, but then that big A would be recessive in males. And that can be really, really confusing to have a big A that behaves recessively, because then in males, the little a is actually the dominant one. I'm going to show you guys that really quick so you can see how it's confusing. And then I'm going to change the way we're doing it. So in females, this trait is dominant. So if I say that big A is spikes and little a is no spikes, and in females, spikes is dominant. So that means that big A, or big A, little a is spikes, and little a is no spikes. Simple enough. But in males, the spikes gene is recessive, aka our big A is recessive. So in males, big A, or little a would mean no spikes, and big A would mean spikes. So you can see how it's really confusing on the male side, because this little a is now the dominant one. Notice that the heterozygous is based on the little a, not the big A. Super, super confusing. So we're not going to do it that way. I'm going to clear the screen. And we're going to start over with something that makes a lot more sense. Just A and B. So using two different letters, not using a big and a small letter because it won't match up like we just did. A, I'm going to say is spikes, and B is no spikes. So in females, spikes is dominant, aka A is dominant. And that would mean that B is recessive. So that means that AA or AB, since the A is dominant, results in spikes, and only BB is no spikes. And in males, we're going to say that instead now, because in males, spikes is recessive, so that means that no spikes is dominant. So B is dominant here, and A is recessive. So notice how that's different from our female side. It's just flipped. So now anywhere that we have a B, that's dominant. So that means that BB, so our homozygous dominant, or being heterozygous, remember our B is dominant, is now no spikes because B equals no spikes. And AA, this is our recessive, would mean spikes. Okay, so that can be confusing to set up, but once you have that, it'll make the rest of the problem go a little more smoothly. So if you need to pause and take some time to just stare at it and try and figure it out, go ahead and do that, because the rest of the problem won't make as much sense unless you really understand where these come from. Okay, so now let's look at our cross. I'm just gonna split the screen. We crossed a heterozygous female. So heterozygous would mean this big A, big B. This is the same thing as saying like big A, little a, except remember we don't want to use those little letters in this type of problem because it's confusing. So she's heterozygous and she's female. That's important. We are going to put those X chromosomes and turn this into a dihybrid cross. So remember the AB, those are autosomal chromosomes, but because this is influenced by sex, we are going to include what sex they are. And the female is crossed with the spiked male. So this is why drawing these little things is really important with the females and the males, because if I just told you spiked male, and you're like, oh, well, spikes is dominant in females, and you forgot that it was a male, you'd be like, wait, I don't know what genotype it is. Because we drew this out, though, you can go and see, okay, it's spikes, and it's a male. So you go to the male side, you look for spikes, he must be AA. And he's a male, so I have to put XY. And notice if I didn't include that XY, and you just saw big A, if it was a female, they would have spikes. Or sorry, that's not a good example. For the heterozygotes, right here, it would be confusing if I didn't tell you it was a female. You wouldn't know if they had spikes or no spikes. Okay, so now we're going to cross these. And remember, whenever you're crossing dihybrids, the easiest way to do it is to take each gene in its own little monohybrid square. So we're going to cross AB with AA and XX with XY. So I know that with my XX and XY, we're going to have half of them girls, half of them boys. If you need to draw out the squares on the side, go ahead and do that. And for my ABs and AA, half would be AA and half would be AB. Okay, great. So now we have that. What do we do now? Well, just like we split up at the top females and males, whenever you're looking at the offspring, you're also going to split it up based on females and males. Let's go to purple. So this is now for the offspring. So our female offspring and our male offspring. So our female offspring have, so just looking at females right now, if they're female, that means they're XX, obviously. And now we look at that autosomal trait. They have a half a chance of being big A and a half a chance of being AB. So if that would be our genotypic ratio. If I were to look at the phenotypic ratio, I'm going to go back up to my female traits in the blue and see, okay, what does this big A, and big A, big B mean? Well, both of those mean spikes. So all are going to have spikes. Now let's look at our males. So our males have the same chances over here of 1/2 big A, 1/2 big A, big B. And so now I look to my blue male square and I see, what does AA mean? Well, that means spikes. What does AB mean? That means no spikes. So that means that I have half with spikes and half with no spikes. So notice it's the same genotypes for my females and males. Half big A, half big A, big B. The same genotypes, but the phenotype here is going to be different. All spikes versus half spikes, half no spikes. So that's why it's really important to consider the sex of the individual that you're looking at, because it will have a different phenotype. So that's sex influence traits. I know they can be confusing when you first see them. Spend some time with it, try this problem on your own and see how you can do. And the next thing that we're going to be talking about is going to be our sex limited traits.
I hope you found this video really helpful. The concepts and information presented in these videos will be true no matter what genetics class you are taking. However, the concepts presented in this video are referencing material currently covered in Baylor University's coursework. Remember, if you are currently enrolled as a Baylor student, we offer free tutoring services. Our tutoring center is located on the first floor of the Sid Richardson building. You will find all the details you need to know about these services on our website, www.baylor.edu/tutoring. You may schedule a free 30-minute one-on-one tutoring session online through Navigate, or just drop in during our open business hours. For more information about our current services, please visit our website. Thank you.